Now, let us discuss another problem. Suppose this is this point A is a shore and a boat is in water. A man is standing in the boat. This is the point A is the shore, boat is in water and the man is standing here. The distance of the man from the shore is 20 meters. Distance of the man from the shore is 20 meters. Now, the man walks 8 meters towards the shore. The man walks 8 meters towards the shore. What would be the effective distance of the man from the point A? What would be the effective distance of the man from the point A? After he walks 8 meters inside the boat, what would be the effective distance of the man from the point A? Assume that boat has mass 40 kg, man mass, actually you can take a boy only, boy mass 10 kg. So, a boy of mass 10 kg is standing here on the other extreme of the boat at a distance 20 meters from the shore, and he starts walking towards the shore inside the boat, and he walks 8 meters inside the boat. When he walks inside the boat 8 meters, what is his final distance from the point A? That is the question. So, how to do this problem? To do this problem, actually the point here is, when he walks 8 meters towards the shore, his initial distance is 20, 20 minus 8 is 12. You may be tempted to say like that, but that is not correct, because when he moves in this direction, the boat will move in this direction. Therefore, his net distance will be slightly greater than 12 meters. So, let us try to find how much it is. Suppose man mass is small m and boat mass is capital M. Man mass is small m, boat mass is capital M. If the man moves 8 meters in this direction, let the boat move x meters in this direction. When the man moves 8 meters in this direction, let the boat move x meters in this direction. Then automatically effective displacement of the man is only 8 minus x. Effective displacement of the man is 8 minus x, because 8 meters in this direction, because he is inside the boat, he should travel along the boat. If the boat moves x, he will also move x in this direction. So, his net displacement will be 8 minus x only. His net change in position is 8 minus x only. Whereas, net change in position of the boat is x, net change in position of the man is 8 minus x. Now, you know this thing, xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. Same old formula. We can always do everything regarding center of mass using these type of things only. So, formula should be minimum, applications should be maximum. That should be the way you have to approach physics. Now, here dxcm is equal to m1 dx1 plus m2 dx2 by m1 plus m2. As usual, you write this formula and take the differential coefficients. Dx center of mass equal to m1 into dx1 plus m2 into dx2. dx1 is change in position of first particle, dx2 is change in position of the second particle. Here in the system, first particle means the man, second particle means the boat. So, what is the change in position of the first particle or man? 8 minus x. What is the change in position of the boat? X. 8 minus x in this direction, x in this direction. So, dx1 is 8 minus x, dx2 is minus x. In this direction, we are taking positive, in this direction negative. That is why 8 is taken positive, x is taken negative. Then, what about this dxcm? when the man is moving, boat will move in this direction, man is moving in this direction, but man and boat are a system, there is no external force acting on the man plus boat system. So, when there is no force acting externally on the man plus boat system, why should the center of mass move? There will be no motion of center of mass. dx center of mass equal to 0. So, 0 is equal to m1 dx1 plus m2 dx2. Now, m1 is man or boy, mass 10 kg given, no? 10 into dx1 means 8 minus x plus m2 is 40 into minus x equal to 0. That means 40x is equal to 10 into 8 minus x. 40x is equal to 10 into 8 minus x, 0 0 gets cancelled, 4x is equal to 8 minus x, 5x is equal to 8, x is equal to 1.6. So, the boat moves 1.6 meters away from the shore. When the boy moves 8 meters, boat moves 1.6 meters away. So, net motion of the boy towards the shore will be equal to x dash is equal to 8 minus x, that is equal to 8 minus 1.6, that would be 6.4. So, 6.4 meters he moves towards the shore. So, his final distance from the shore will be 20 minus, his final distance from the shore will be 20 minus 6.4, that would be 13.6 meters. So, like that we can do this type of problems using this analysis only. dxcm equal to m1 into dx1 plus m2 into dx2 by m1 plus m2. Only thing is you should carefully substitute what is dx1 and what is dx2. We will do some more examples also to clarify that. It is an easy thing, nothing difficulty in this. Next, second one. Now, take this example. An isolated particle of mass m is moving in a horizontal plane along the x-axis at a certain height above the ground. It suddenly explodes into two fragments of masses m by 4 and 3m by 4. So, they are moving, actually a body of mass m is moving along x-axis. Suddenly it explodes into two fragments like this. One is m by 4, another is 3m by 4. At an instant later, the small fragment is at y equal to plus 15. Plus 15 means in this direction. Small fragment means m by 4, which is at a distance 15 units. 15 units or 15 centimeters. Now, second one is moving in this direction. We want to find what is this value. Actually, it is moving along x-axis means there is no motion of center of mass in the y-axis direction. So, as far as y-axis is concerned, center of mass is at rest. As far as y-axis is concerned, center of mass is at rest. Therefore, if one fragment travels like this, another should travel like this in such a way that center of mass should be again at this point. So, what we can write, we can use this relation m1 r1 is equal to m2 r2. m1 r1 is equal to m2 r2 means this is the center of mass. So, this distance must be equal to this, not this distance, m by 4 into this distance must be equal to 3m by 4 into this distance. So, use this relation here, because center of mass of these two parts should be here at origin only. We know that when two particles m1 and m2 are separated by some distance, if center of mass is at a distance r1 from m1, r2 from m2, then m1 r1 equal to m2 r2. This relation is always valid. If the center of mass is at a distance r1 from m1 and r2 from m2, always m1 r1 must be equal to m2 r2. Same thing we are applying for y axis. the particle is moving along x-axis only, so there is no motion of center of mass along y-axis, it is always at this point only. Therefore, as far as y-axis is concerned, no motion of center of mass. So, here this relation should valid. Therefore, m by 4 into 15 is equal to 3m by 4 into y. M by 4 gets cancelled. Y is equal to 5 centimeters. Actually, this is down, no? That is why you can say that minus 5 centimeters. So, y is equal to minus 5 is the answer. This is also a previous IIT problem. See how easy they are. Actually, if you apply the principles, every question appears to be simple. Next one, see there are two blocks of masses 10 kg and 4 kg which are connected by a spring of negligible mass and placed on a frictionless horizontal surface. There are two blocks 10 kg and 4 kg. Two blocks 10 kg and 4 kg which are connected by a spring of negligible mass. So, they are connected by a spring of negligible mass and are placed on a frictionless horizontal surface. There is no friction on the surface to hamper the motion. An impulse gives a velocity 14 meters per second to the heavier block. So, an impulse, a sudden jerk is given to this so that it acquires a velocity v equal to 14 meters per second. It acquires a velocity 14 meters per second in this direction, in the direction of 4 kg block. The velocity of the center of mass is how much? So, here even though both the blocks are at rest initially, we cannot say that center of mass won't move when we apply impulse on this. When we apply impulse on 10 kg means we are applying a sudden force on the 10 kg block. So, there is an external force on the system. Therefore, what we have to do is how much velocity it acquires after this impulse. See, the problem here is impulse will give velocity and then the force disappears. A sudden force gives velocity and it disappears, means there will be no more continuous force on the system. There will be no more continuous force on the system. Force is just for a moment it acts and then it is ceased or stopped. Therefore, after this force is withdrawn, the system, these two particles system has velocity 14 meters per second for this one, 0 velocity for this one immediately after the impulse. Now, center of mass velocity means you have to apply the relation m1 v1 plus m2 v2 by m1 plus m2. You can apply like this. m1 is 10 kg, v1 is 14 plus m2 4 into 0 by m1 plus m2 means 10 plus 4 14. So, this is 0 anyway, 14 gets cancelled. This is 10 centimeters per second, 10 meters per second, because this is in meters, you will get this also in meters. So, 10 meters per second is the velocity of center of mass and that continues to be same. After any length of time, if there is no external force acting further, it will be only 10 meters per second. That is how we should do this problem. Next one you see, a circular plate of uniform thickness has a diameter 56 centimeters. A circular portion of diameter 42 centimeters is removed from it. See, this is the circular plate of which this is removed. Suppose the original center of the circular plate is O, center of the removed portion is O dash. This is the removed circular part, this is the original circular part. And we are given that diameter of the circle is 56 centimeters. That means radius will be 28 centimeters. Diameter is 56. So, radius of the original circle is 28 centimeters. Now, this is the removed circular plate whose diameter is 42 centimeters, therefore whose area will be equal to 21 centimeters, whose radius will be equal to 21 centimeters. So, the removed circular part has radius 21 centimeters, whose center is at O dash. So, distance between these two centers is 7 centimeters. Now, this is the removed part, this is the removed part, this is the remaining part. This is the remaining part. Now, remaining part, let us suppose, has a center of mass at this point C. Original center of mass for both the parts is O. When both are combined, it is a single plate whose center of mass is at O, and center of mass of the removed part is at its center here, O dash. So, the question is where you will find the center of mass of the remaining portion. The question is find the center of mass of the remaining portion. Let the center of mass be here for the remaining portion. Let the mass of the remaining portion be M1. Mass of this plate be M2. Removed plate mass is M2. Remaining plate mass is M1. When M1 and M2 are again combined, you will get the center of mass at O, because it is a single plate. You will get the center of mass at O. So, M2 is at center of mass O dash, M1 is at center of mass C. Then, when M1 and M2 are combined, we will get a single plate where the center of mass of both of them will be equal to the original center of the circle. Now, you apply the same formula, M1 R1 is equal to M2 R2 here. M1 means mass of this plate, which is equal to pi into, which is proportional to area of this, which is equal to pi into 28 square minus 21 square, total plate minus this plate area. Mass is proportional to area for two dimensional objects, that is why we are taking like this, into, let the distance of this from the original center of mass be x, into x is equal to M2 into, M2 means pi into 21 square, mass of the removed plate, mass of the removed plate, into this distance O dash 7. Then pi gets cancelled, a square minus b square is a plus b into a minus b into x is equal to 21 into 21 into 7. 7 gets cancelled, 7 sevens, 7 threes, again 7 sevens, that is 7 threes again, sorry, 7 threes. So, x is equal to 9 centimeters. That means this distance is 9 centimeters. So, the center of mass of the remaining portion will be at a distance 9 centimeters from the original center of mass. Thank you. In the next class, we will discuss about the center of mass frame and what advantage is there for us using the center of mass frame.